This one has two terms. What method should we use for number 1? Good. How'd you know that? Two things how you know that it's difference of squares. First one is there's a what? Two perfect squares, and there's also a what? Minus sign. Okay, so tell me what this factors into. Good. X minus 3, x plus 3. And then on all of these, we're going to solve after we factor it. So our two zeros here are what? Good. Alright, and then also on these, we're going to add up our zeros to make sure that it equals our degree. So like here we have how many answers? And our degree? Good. If it doesn't match up, like if you have 2 answers but the degree is 3, that means you still haven't solved for 1. Any questions about that one? Is the next one the difference of squares too? Because there's what? Plus sign. But notice that the middle term still cancels out, right? And we'll still need what in the first part in each binomial? X and x. We know it has to be a plus and a minus if the middle cancels out. What are going to be our two terms right here? Can anybody think of it? Good. 3 what? On both. Now, I don't know how you came up with that, but like most people can't think of that off the top of their head. So if you can't think of what goes here, we could look at this like algebra, so ignore this for a second. How do I get x by itself? Subtract 9, and then take square root of both, and the square root of this is what? Plus or minus 3i. Okay? So if you can't remember it, then do it that way. So anytime it's a sum of squares, there's always going to be an I, always. So what are our two solutions? And what's our degree? 2. So we found both of them. Another thing. What are we truly finding right here? What are these called that we solve for? But what are they? X-intercepts. Good. Okay, so this one would touch our x-axis 2 spots. How many times would it touch our x-axis here?
2.
None.
None, because these are what?
Imaginary.
So let me show you. Can I borrow your calculator for a second, Jenna?
Yes, ma'am.
You don't have to do this because you know how to graph, but I'm going to graph it and show you what it looks like. Y equals, clear that out, x squared plus 9. And when you graph it, you can see it's like way up here. It'll never touch the x-axis. But it still has zeros. They're just imaginary. Okay, so imaginary zeros will not touch the axis. Alright, do 3 and 4 on your own. Make sure you solve for them. Make sure it adds up to be your degree. When you get done with these, feel free to talk to people around you about what they got. Look at 4, because you have 2. Here's the answers if you want to check them.
Can you show us?
I can. Okay, so on number 2, could you do difference of squares on that one? You had to use what? What'd y'all do? Yes, pull out 3x. That's called GCF. And then we got x minus 3 on the inside, and that's how we got these 2 answers. Everybody cool with that one?
Mm-hmm.
Alright, on this one, this is what type? Very good. Difference of squares. So what does it factor into, the first 2?
2x.
Alright, tell me how you got 2x.
2x squared.
Tell me I got 2x squared.
Because 2x squared times the sum of the squares.
Very good. And then what goes here?
Minus 5.
And plus 5. Good. Any questions about that part? Okay. So when I set this one equal to 0 and move the 5 over, it'll be what over here? 5. Then we have to divide everything by what? And now? Square root both sides. We don't know the square root of this one, so you can leave it 5 over 2, but you need what? Plus or minus. That's how many answers? 2. This one's the same thing, except it's going to be a negative 5 over here. So when you take the square root, you'll have a what on the outside? Ah. Very good. How many answers are here? Good. All together there's 4, and that's our degree. See how it adds up? How many times would this polynomial hit the x-axis? Twice. Once at square root of 5 over 2, again at negative square root of 5 over 2. Won't touch here. Does everybody understand? Any questions? Alright, let's see if we remember difference and sum of cubes. Okay? Can anybody tell me the formula for sum of cubes? Do y'all remember? Go ahead. A plus B. Almost. Perfect. We all cheating? Okay, good. So if it's sum of cubes, well, first of all, it has to be a perfect cube on each one for us to do sum of cubes. Otherwise, we can't do it. Just like sum of squares and difference of squares. And then you just take the first 2 terms, the cube root of both, square the first term, square the last term, multiply them together. These 2 are the only ones that are going to change, these 2 signs. They will always be different. How do you know which one to start with? Because if sum of cubes, you bring the sum over. But then it has to be different right here. Difference of cube is the same thing, except we change these 2 signs. So it'd be A and
A squared plus AB plus B.
yes. Again, these signs are the only ones that change, these middle ones. Alright, so on number 5, is this sum of cubes or difference of cubes? How do you know? Good. And also because 8 and 27 are both what? Good. So what's the cube root of this first one? 2 what? Here? Very good. So this is our A, this is our B. Not the original numbers, but the cube root of each one, that's our A and B. Do we start it off with A plus B or A minus B? Good, because it's minus right here. So 2x minus 3. Then we have A squared. So what's A squared? Try it again. Good. Then we do A times B. Minus or plus? Good. And then the last term squared? Very good. Now to solve. Any questions about this part though? What's this one going to be? 3 over 2. Alright, what are we going to do about this one? Factor it? Okay, so we'd have to use what to factor?
Basic one.
Okay, so we'd start by doing 9 times 4? 36. So what are the factors of 36 that can add to 6? There are none. Okay? So what are some other ways we can solve polynomial or quadratics without factoring? Quadratic formula, or you could graph it, or we could do completing the square. Which one y'all want to do? Graphing? Completing the square? Y'all like completing the square? This has a number in front. Okay. We're going to do quadratic formula. Do we need to sing it or no?
No.
Okay. Then tell me how it starts. -6 plus or minus square root of minus. Perfect. All over. Good. Alright, I want you to take time to find the discriminant. That's the part underneath the square root. Make sure that we can get the same thing in our calculators because my other class are having trouble. So let me know what you get. What did everybody get? Negative. Did everybody get that? Okay. So we got -6 plus or minus square root of -108 all over 8. What is a perfect square that can go into 108?
9.
Bigger.
36.
36. How many times?
3.
Okay. So we got -6 plus or minus square root of -36 times 3 all over 8. Square root here? Good. So -6 plus or minus 6i square root of over. And then finally, we can simplify this by taking a what out of everything. So tell me final answer. Good. How many answers is this right here? How many here? 1. So our degree is 3 and we have 3 answers. Now, difference of cubes and sum of cubes. This one right here, you'll never be able to factor it. Okay, so don't waste your time on doing that. Also, if we were to try to do this by graphing, we would find our solutions. Tell me why. Because it's imaginary. So you have to do quadratic formula. Anytime it's sum or difference of cubes, you have to do quadratic formula to solve this part. And it'll most likely always be imaginary.
Is there any instances where you can factor?
Right here, not for sum and difference of cubes. Nope. So we are going to skip number 6 and come back to it because it will take the most time and I want to get through these notes. So moving on to number 7, but first, any questions about this? How many times would this touch the x-axis? Once. Good. Alright. Tell me how you would do number 7. Oh, nothing. We're just going to come back to it. And then what would go in the middle? Plus. Can we factor this one? Into what? Very good. So what would our zeros be? How many answers? But our degree's 4. Very good. So this one has multiplicity of 2. So it's really twice. So there is 4 answers here. Yes, not twice, but it like bounces off of it. So the multiplicity is 2, and that's what has to add up to be the degree. All right, try number 8 on your own. And you'll use AC Easy to do that one. Just heads up. Alright, I'm going to write the answers up here, and if we need to go over it, I can. It was x equals plus or minus 3i, x equals plus or minus I squared of 2. Do I need to go over it? Okay. So I'll move the 18 over first, and then this one, don't let the x to the 4th trip you up. If it has a 1 in front and an even right here, and this has no x, you just do AC easy. What are factors of 18 that can add to be 11? Good. And the only difference between what you've been doing and this one is instead of x in each one, you'll need what? Because x squared times x squared is x to the 4th. And then from here, set this equal to 0, you get x squared equals negative 9. And that's how when you take square root, you'll have 3i. And then right here, you'll get negative 2. That's when you take the square root, you'll get I squared of 2. How many answers? 4, which matches our degree. How many times would this polynomial hit the x-axis? None. It wouldn't hit it at all. Questions? Alright. We won't spend a lot of time on these because I feel like grouping is the ones y'all do the best on. So let's just do one together, then do one on your own. Then we'll call it a day. Alright. On number 9, we go ahead and group them. And how do you know when to use grouping? Good. What comes out here? In the middle? X plus 3. What do these have in common? And then x plus 3. So we'll have x plus 3 and
X squared.
what's one of my zeros going to be?
And plus
Very good. Alright. And there's 3 answers, our degree is 3. Once you have finished 10 and 11, and I've seen it, you can pack up. I just want to say while y'all are working on that I went through this pretty fast. So